Hello everyone. Today we are going to be talking about quadratic equations and how to solve them by completing the square. So the topics we will cover include what actually is a quadratic equation, how to solve a quadratic equation by completing the square, what do we actually mean when we say we have found a solution to a quadratic equation, and then plotting the quadratic equation to see the solution on a graph, basically visualizing the solution of a quadratic equation. So let's make a start. The word quadratic comes from the Latin word quadratum, and quadratum means square. So a quadratic problem is a problem that deals with a variable that is multiplied with itself. Let's say x is a variable, and when we multiply x by x, we get x squared. So a quadratic equation is an equation in which a variable's highest power is 2. The basic form of quadratic equation is ax squared plus bx plus c. And in our future video lessons, we will have more discussion about the quadratic equations and their use for real-life problems. So let's look at an example. Let's say we have a quadratic equation 3x squared minus 8x plus 5 equals to 0. And because we will solve this quadratic equation by completing the square, it makes sense to compare our quadratic equation with the perfect squares. So we know there are two common perfect squares, a plus b squared, which is equal to a squared plus b squared plus 2ab, and a minus b squared, which is equal to a squared plus b squared minus 2ab. In the case of our given equation, it resembles more with a squared plus b squared minus 2ab. And why does it resemble with this? This is because there is a minus in front of 8x. If there was positive sign in front of 8x, then we would have said that our given equation resembles more with a squared plus b squared plus 2ab. And we would have used that equation to solve the quadratic equation. But because we have a negative sign in front of 8x, we will use a squared plus b squared minus 2ab as a reference to solve our quadratic equation. In the equation a squared plus b squared minus 2ab, a is a variable, and in our equation x is the variable. So it makes sense to compare our first term with the first term of a squared plus b squared minus 2ab. The first term in this equation is a squared, and the first term in our given equation is 3x squared. Now we see that the coefficient of a squared is 1, and in our case the coefficient of 3x squared is 3. In order to make our given equation resemble more with a squared plus b squared minus 2ab, we need to rearrange the equation so that the coefficient of x squared is 1 in our equation, not 3. So let's try to do that. Let's divide the entire equation by 3 so that we get rid of coefficient 3. Once we do that, we get x squared minus 8 by 3x plus 5 by 3 is equal to 0. Now let's compare this with the equation a squared plus b squared minus 2ab, which is one of the perfect squares that we are using as a reference to solve this equation. We see that x squared can be taken as a squared, 8 by 3x can be taken as 2ab, and because x squared is equal to a squared, the value of a will be x. And when we replace a with x in 2ab, we get 2xb, which is equal to 8 by 3x. X cancels out, and we get 2b is equal to 8 by 3. We divide 8 by 3 by 2, and we get the value of b as 4 by 3. So just by rearranging the quadratic equation that we were given and comparing it with a squared plus b squared minus 2ab, we can see what a and b actually is. And we will use this knowledge to complete the square and find a solution for the quadratic equation. So let's try to further rearrange the quadratic equation and try to write it in the form of a square plus b square minus 2ab. So we know that a is equal to x, so a square will be x square. We know that b is equal to 4 by 3, so b square will be 4 by 3 square. And we know that 2ab will be 2 multiplied by x multiplied by 4 by 3, which will be 8 by 3x. And 5 by 3 was part of the original quadratic equation, so we will retain that on the left hand side. But because we have added 4 by 3 square on the left hand side of the equation, we will also add it to the right hand side of the equation so that the entire equation remains balanced. And when we do that, we take 5 by 3 to the right hand side of the equation. And now when you look at the equation, you see x square plus 4 by 3 square minus 2 times 4 by 3 x. So this left hand side of the equation resembles more with a square plus b square minus 2ab, which means that the left hand side of the equation is now a perfect square, and it's a perfect square of x minus 4 by 3. So now that we have completed the perfect square of the quadratic equation on the left hand side, we will find the value of x by solving this entire equation. We open the square on 4 by 3, which is on the right hand side, we get 16 by 9. We try to solve the right hand side of the equation. By solving the right hand side of the equation, we get 1 by 9 on the right hand side. So we get x minus 4 by 3 square is equal to 1 by 9. We take square root on both sides to eliminate the square, and we get x minus 4 by 3 is equal to plus minus 1 by 3. Remember that when we take a square root of a value, we always add plus and minus. We always add plus and minus to the value. So now we have x minus 4 by 3 is equal to 1 by 3, and x minus 4 by 3 is equal to minus 1 by 3. So this tells us that there are two values of x for this quadratic equation. So let's try to get these two values of x. We take minus 4 by 3 to the right hand side of the equation, we get 4 by 3 plus 1 by 3. We solve the right hand side, we get x is equal to 5 by 3. So that is the first value of x for this quadratic equation. Now let's try to find the second value of x for this quadratic equation. We take minus 4 by 3 to the right hand side of the equation, we get x is equal to 4 by 3 minus 1 by 3. We try to solve the right hand side of the equation, we get x is equal to 3 by 3, which is 1. So we get the second value of x as x is equal to 1. So now we have two values of x for the quadratic equation. And why do we have two values for this quadratic equation? Because the highest power of x in this quadratic equation was 2. So the number of values of x will depend on the power of x in the quadratic equation. Because we had x square in the quadratic equation, with square being the highest power of variable, we get two solutions. If we were given an equation in which we had x cubed, which means that the highest power of the variable was 3, we would have noticed that there would be three values of x. So now that we have got two values of x for our quadratic equation, we can say that we have solved the equation, and we can write these two values of x within the bracket as 5 by 3, comma 1. So what do we actually mean when we say we have found a solution to the quadratic equation? So what we mean is that when we replace x by 5 by 3 or we replace x by 1 in the quadratic equation, the left hand side of the equation should become 0. And that's one way to check whether the answers that you have found for x are correct or incorrect. So let's do a check. Let's try to replace x by 5 by 3 in the quadratic equation and see what happens. So the equation becomes 3 multiplied by 5 by 3 square minus 8 multiplied by 5 by 3 x plus 5. When we solve this, we get minus 15 by 3 plus 5, which is equal to minus 5 by 5, which is equal to 0. So by replacing x with 5 by 3 in the quadratic equation, the left hand side of the equation becomes 0, which tells us that the value of x that we have calculated is correct. Now let's do it for the other value of x that we have calculated. Let's try to replace x with 1 in this quadratic equation. So the equation becomes 3 multiplied by 1 square minus 8 multiplied by 1 plus 5, which is equal to 8 minus 8, which is equal to 0. So again, the left hand side of the equation becomes 0. So this tells us that the second value of x we have calculated is also correct. So this is one easy way to check whether the solution that you have found for the quadratic equation is a correct solution or not. And then there is another way of finding the solution to the quadratic equation. You can actually plot the graph of the equation to find the solution of this quadratic equation. And what do we mean when we say we are plotting a graph of the equation? So if you look at the equation, the original equation was 3x squared minus 8x plus 5 is equal to 0. So when we have to plot a graph of the equation, we equate the left hand side of the equation to y, and then we try to find the value of y against different values of x, and the value of x that will make y equal to 0 will be our solution. It is similar to checking the solutions that we calculated by completing the square. Remember, the solution that we calculated by completing the square made the left hand side of the equation equal to 0. So we will use the same principle, but we will use a graph to see at what values of x y is equal to 0. So let's do that. So to plot a graph, we have to find several values of y by inserting several values of x in this equation. So what we have done over here in this graph is that we have started with the value of x equal to 0 in this equation. So when we put x is equal to 0, the equation becomes y is equal to 3 multiplied by 0 minus 8 multiplied by 0 plus 5, which is equal to y is equal to 5. So when the value of x is 0, the value of y is 5, which is what you see in the graph on the left hand side of the graph. And then we have inserted different values of x at an increment of 0.1. So after inserting the value of 0, we inserted the value of 0.1 to calculate the value of y, and then the value of 0.2 to calculate the value of y, and then we inserted the value of 0.3 to get the value of y, and so on. So we get this nice little shape of the graph, and we can see the values of x at which the value of y is equal to 0. So what are those values? One of them is x is equal to 1. At x is equal to 1, the value of y is equal to 0. And this is what we were talking about by doing a cross check in our previous step. So this is the visual proof of a solution of the quadratic equation. At x is equal to 1, the value of y is equal to 0. And is there another value of x at which y is equal to 0? Yes, there is. At x is equal to 5 by 3, the value of y is again equal to 0. So by plotting a graph of this equation and calculating the value of y, we can see that the solutions we have found actually make the left hand side of the equation 0. So I hope this has been helpful to visualize the solution of our quadratic equation. In our future video lessons, we will talk about other methods of solving the quadratic equation, and we will also talk about the real-life application of quadratic equations. One such application could be a child throwing a ball in the air and the ball following a projectile motion. and we can find the properties of that projectile motion and that trajectory by using quadratic equation, and we will discuss that in our future videos. I hope this video lesson has been helpful to you. If you have any questions, please leave them in the comment section and I will do my best to respond to your questions. And have a great day. Bye.